Hello everybody, welcome to lesson 7.2 of geometry, similar polygons. Today's learning objectives are use the definition of similarity to identify similar polygons and solve problems by using the properties of similar polygons. Let's look first at the definition of similar polygons. Two polygons are similar if one can be obtained from the other by dilation or by dilation with one or more rigid transformations. A dilation is a type of similarity transformation. A similarity transformation occurs when a figure and its image have the same shape but not necessarily the same size. So let's look at this figure. Determine whether the given polygons are similar. Okay, so if they are similar in shape but different in size, then they're similar. If we look at this large one, okay, and this small one, this is half the size of this. So if side ML is from 10 to 18, that's 8, right? And this one is 4. Same thing here. This is 4. And this is 2. So this small image is a shrinkage of this. So the scale factor is 0.5. Okay. Now we do this in 2 steps. First, we dilate this by half to get this. Okay. And then how do we get from this to this? We do a rigid transformation. A rigid transformation means moving the figure as is, as one piece, either to the left, to the right, or across the x, flip it across the x-axis, across the y-axis. These are called rigid transformations. You're not changing the shape, you're just moving the object as one piece from one place to another. So if you look at this, we're moving down 2 units and left 4 units. So that's our rigid transformation. We say that's -2, and then, we start with x, -4, and then -2. -4 because we're using the x, we're moving the x 4 units to the left, and then -2, you're moving the y 2 units down. Okay, so again, these two polygons are similar. Why? Because one of them is a shrinkage of the other, and then it's translated or transformed 4 units across the x-axis and 2 units across the y-axis. Alright, let's look at this exercise. We want to see if figures A, B, C, D, and K, L, M, N are similar polygons. Pause the video and try to think about this. If your answer is yes, you're correct. As we can see, these, if you dilate this by a scale factor of 0.25 or 1/4, you get this. Okay, so let's try that. Dilate. Now this point is 8, 4. If you multiply 8 and 4 by 1/4, you get 2, 1. So 8 divided by 4 is 2. 4 divided by 4 is 1. So this point becomes right here, and this point will be right here, and this point right here, and this point right here. Okay, let's draw a square right here. Alright, so this image this is, or this small image is a dilation of this large image with respect to the origin by a factor of 1/4. Okay? Now, how do we get from this to this? Okay? As you can see, the axes are not changed. So, to go from here to here, you move the axis by 0. Every point is on the same x. And then you move the y by, so this point, 1, 2, 3. 3 units. Okay? So, at the end, we can say that this small one is similar to this because it's a dilation of, with a factor of 1/4. So, k equals 1/4. Okay? And a rigid transformation along the vector 0, 3, which means x's stay the same and the y's are shifted 3 units up. So each one, this point 1, 2, 3 right here, this point 1, 2, 3, this point 1, 2, 3, this point 1, 2, 3. Okay, so since we obtained this by a dilation of this and then a rigid transformation along the vector 0, 3, we can conclude that these two are similar polygons. All right. Let's look now at the properties of similar polygons. When two polygons are similar, there are important relationships among the polygons, angles, and sides. Basically, the corresponding angles are equal and the corresponding sides are proportional. So, if we look at these A, B, C, D in the same order, angle A equals angle W, and angle B equals angle X, and angle Y equals angle C, and angle Z equals angle D. So corresponding angles are equal and corresponding sides are proportional. So if you divide any two corresponding sides, you get the same ratio. So AB right here over WX. This one divided by this one is the same as dividing BC by XY, is the same as dividing CD by YZ, is the same as dividing AD by WZ. Alright, let's look at an example. So right here we're given that NPQR is similar to UVST in that order. Okay, list all pairs of congruent angles and write a proportion that relates to corresponding sides. So since these two are similar polygons, okay, this means similar. Okay, so this sign means similar. Remember, for congruent it was like this. Okay, we're just dealing with similar now. So since these two polygons are similar, we can say that angle N is congruent to angle U, and angle P is congruent to angle V, and angle Q is congruent to angle S, and angle R is congruent to angle T. Alright? At the same time, since they're similar, we can say that sides NP over UV equals PQ over VS equal QR over ST equal R n over TU. So the sides are proportional and the angles are congruent. Let's look at a more practical example. Alright, we're given that these two polygons are similar and we're asked to find x and y. Alright, so if these two sides are similar, which means RST similar to MNP, we can conclude that RS over MN equals ST over NP equals P or RT over MP. Okay, now we're given that RS is 32 over MN is 16, which is 2. So all of these should be equal to 2. So we can say right here that we know that ST over NP equals 2. Now ST is X over NP is 13 equals 2. That means X equals 2 times 13, 26. At the same time, RT over MP equals 2. RT is 38 over Y equals 2. That means Y equals 2Y equals 38. That means Y equals 19. Alright, I hope that helps. Please pause the video and try to do this yourself. Now for our last example, we want to check if these polygons are similar. If we look at this, angle W is congruent to angle P, and angle X is congruent to angle Q, and angle R or Y is congruent to angle R, and angle Z is congruent to angle S. If that's not enough, we need to make sure that the sides are proportional. So let's look at the size. 12x over PQ, and then xy over QR, and then yz over RS, and then wz over PS. Wx is 12 over 8, and this one is 18 over 12, and this one is 15 over 10, and this one is 9 over 6. If you calculate all these ratios, this is 1.5, this is 1.5, 1.5, 1.5. So since all the angles are congruent and all the sides are proportional, they have the same ratio, we conclude that yes, they are similar. Alright, I hope that helped. Please pause the video and try to redo this yourself, and don't forget to subscribe, leave some comments, and we'll see you in the next video. Bye for now. Stay safe.